If you've ever heard computational linguistics, NLP and AI thrown around as if they're the same thing, they aren't. They're three names for almost the same thing, and the difference between them tells you 50 years of academic politics. Today, untangling the mess, what each of these fields actually is, and why the split matters for the running puzzle we started last time. Last time we met Alan Turing, and the question he asked in 1950, and we set up the running puzzle. Do machines that talk to us actually understand language, or are they just very good pattern matchers? If that puzzle is the spine of this whole course, the field itself has a spine too, and it's split. There's a linguistics camp and an engineering camp. Both camps want machines to deal with language. They disagree, sometimes loudly, about whether the machine has to actually understand anything, or just behave as if it does. Today we map that argument onto three names. Three names, three traditions. We'll go through them in order. Biggest umbrella first. First, AI, artificial intelligence, the parent field that contains everything else. Second, computational linguistics, the older, linguistics-led tradition. And third, NLP, natural language processing, the engineering-led tradition that's eaten the world in the last 20 years. AI is the umbrella. It was named in 1956 at a small summer conference at Dartmouth by a mathematician named John McCarthy, who wanted a fresh label for making machines do the kinds of things humans need intelligence to do. Notice the framing? It's behavior-based from the start. McCarthy didn't say machines that are intelligent. He said machines that do intelligence-shaped things. That's the same move Turing made 6 years earlier. Describe what you can measure, not what you can't. Under that umbrella sit pretty much every approach you've heard of. Computer vision, robotics, reinforcement learning, planning, search, and the one that matters for us, language. And under the language sub-bubble, two siblings, computational linguistics and natural language processing. Both deal with language. Both live inside AI. They just got there from different doors. Computational linguistics came in through the linguistics door. Its founding question was, language has structure. Rules, patterns, hierarchies. Can we describe that structure formally enough for a computer to use it? The big moment was 1957. Noam Chomsky published Syntactic Structures and showed that sentences have a deep grammatical structure beneath the words you actually hear. Suddenly there was something formal to encode. From that point, CL meant write down rules of grammar, build a parser that applies them, and let the machine figure out what a sentence means by figuring out how it was built. Bottom-up understanding. The thing to remember about CL is its goal. Not just that the machine works, but that the machine works for a reason a linguist could endorse. Understanding first, performance second. Natural language processing came in through the engineering door. Its founding question was almost the opposite. Forget understanding for a second. Can we build a thing that works on this specific task? Translate Russian to English. Sort spam from real email. Pull the names out of a news article. NLP didn't care if the machine had a theory of language. It cared if the score went up. The big turning point was the early 1990s. Peter Brown and the IBM team showed that throwing statistics at parallel translated text beat handwritten grammar rules. That was the moment engineering started winning. The thing to remember about NLP is its goal. Does it work? If yes, ship it. If a linguist can't explain why, that's the linguist's problem. So here's the punchline. Through the 70s and 80s, CL had the prestige. Universities had whole linguistics departments, conferences, journals. NLP was the scrappy upstart. By the late 1990s, the prestige flipped. Statistical methods kept winning benchmarks. Then neural networks. Then transformers. Then GPT. By 2026, when most people say NLP, they mean huge language models. And when they say computational linguistics, they sometimes mean the same thing, sometimes mean the older grammar-based stuff, depending who's talking. But here's the surprise. The CL questions never went away. They've come back hard in the last few years under new names: interpretability, alignment, symbol grounding, mechanistic understanding. Translation. The engineers won the benchmarks. then realized they didn't actually understand the system they'd built, and started asking the linguist's question from the other side. Quick recap. 3 names, 3 working definitions. AI, the parent field, any machine doing anything that humans need intelligence for. CL, the linguistics tradition, formal models of language structure, parsers, grammars. Understand first. NLP, the engineering tradition, whatever method makes the benchmark go up, behave first. Quick check. 3 questions. First, which is most associated with the linguistics-led tradition? A statistical machine translation. B. Generative grammar and parse trees. C. Backpropagation. D. Benchmark leaderboards. B. Generative grammar and parse trees. Chomsky, 1957. A and D are engineering. C is a general machine learning tool. Next one. Who coined the term artificial intelligence and where? A. Alan Turing in his 1950 paper. B. Chomsky at MIT. C. John McCarthy at the 1956 Dartmouth conference. Or D. Joseph Weizenbaum while building ELIZA. C. John McCarthy, 1956 at Dartmouth. Turing posed the question of machine intelligence earlier, but the field's name comes from McCarthy's summer conference. Last one. After NLP won the benchmarks in the 2010s and 2020s, what did engineers eventually realize? A linguist had been right all along. B. They didn't fully understand the systems they'd built. C. Benchmarks were a perfect measure of understanding. Or D. The Turing test had been passed. B. They didn't fully understand the systems they'd built. The CL questions came back from the other side as interpretability, alignment, symbol grounding. Nobody declared the Turing test passed. That fight is still on. Back to the story. So, back to the running puzzle. When you ask, does ChatGPT actually understand language? You're not asking a neutral technical question. You're picking a side in a 50-year argument. And the field itself is still arguing. Which means for the rest of this course, when we look at any technique, parsers, embeddings, transformers, RLHF, you should ask, is this a CL move or an NLP move? Is it trying to understand or trying to behave? Both are valid, they're just not the same. Next time we travel back to 1954, when a single demo in New York convinced the entire field that we'd already solved translation. We hadn't. It would take another 60 years.